Okay, so relative velocity 2011, question 2, part B. A woman can row a boat at 4 meters per second in still water, and she rows across the river 80 meters wide. The river flows at a constant speed of 3.5 meters per second, parallel to the straight banks. She wishes to land between B and C, so along here. The point B is directly across from A, and the point C is 20 root 3 downstream from B. If theta is the direction she takes, find the range of values for theta if she lands between B and C, and this diagram is given the black parts. Okay, well, we have the speed she can row at, and we have an angle going in this direction, so let's create a triangle here with the speed of the river. So she can travel out that way at 4. The river is going this way at 3.5. And that would be a right angle, and that's theta. So we have A and H, so the cos of theta is equal to 3.5 over 4. So in this case, theta will be, calculator, 28.955 degrees. Let's create another diagram then. So if we take C over here, coming down to the point A, and she's going in this direction. Let's try to get a better line than that. She's going in this direction at 4. We continue that along there to create a triangle. We know that the river can flow that way at 3.5. That's a 4. That looks like a U. A 4. Okay, let's call this angle, these are corresponding angles. We call this angle B. This angle B. We call this angle A because it's beside A. And we still have our theta in here. Theta is in there. So I take this little triangle maybe and just do it like this. 3.5. That was a 4. So this triangle here going over to here. A B and an A. So we have 2 unknowns here. So let me jump up here then. Let's create this triangle because we've got variables up here. This is still B. This is 20 root 3, and this is 80. So this will be brilliant for us. This will give us the 2 straight sides. So the tan of B, which will help me now down here, the tan of B is equal to 80 over 20 root 3. And that would make B 66.59 degrees. So now I can use the sine rule down here. I can say that the sine of A, this will help me get A, the sine of A over 3.5 is equal to the sine of 66.59 divided by 4. So 3.5 sine 66.59 is equal to 4 sine A, or divided by 4 equals sine A. And this would give an inverse sine. Inverse sine of that is going to give me A to be 53.41 degrees. So now that will help me find the second value for theta, because if we look up here, these are alternate angles. So I can put theta inside there, and we can now just say that theta is going to be equal to 180, the 3 angles in the triangle, minus B minus A. So 180 minus 66.59 minus 53.41. That looks like it works out evenly. 41 and 59 is 1, and 119, so that's 120. So theta will be equal to 60 degrees. So my range of values to land between B and C are these two. So I can say theta less than or equal to 60 degrees, less than or equal to 28.955. That's my answer.